This right here is a ball. But it's not just a ball. It's a blue ball, it's a snazzy ball, but most importantly, it's an energetic ball. Now this ball likes to keep its energy. If it gets excited, it's going to stay excited, unless something specifically stops it. But until then, it's going to keep its energy. In fact, one could say that it's going to conserve its energy. Now what does energy to this ball look like? Well, it can look like one of two things. It can look like the ball moving, or it can look like the ball wanting to move. And, as a matter of fact, it can look like both of these things at the same time. Now when the ball's rolling around on the ground, it's pretty obvious that the ball is using its energy by moving. Some would call this form of energy kinetic energy. However, if we move the ball up a bit, the ball knows that it has the potential to gain energy by being pushed down by gravity, since it's no longer being stopped by the ground. But since the ball prefers to actually move rather than having the potential to move, it's going to take whatever opportunity it can to convert the potential movement into actual movement. The same idea applies even if the ball is up on a cliff. Even though the ball is stopped by the ground, it knows that if it were to move slightly to the right, it could convert all of that potential movement into actual movement, considering its height. But for as long as the ground is there to stop it, it's going to sit there like a child high on candy at 2 a.m. after Halloween, anxiously waiting for it to move the 2 inches to the right to release all of that potential it has. Some would call this form of energy gravitational potential energy. Now, no matter the form that the ball is using energy, it will always have the same amount. Even if it's just sitting there anxiously waiting to release that energy, it knows that it can eventually release it, and will just sit there and wait until it can. This can be thought of as the conservation of energy. However, just as my mom used to tell me, nothing in life comes for free, and the same applies to this ball. The ball isn't born with all of that energy given to it, so it must gain it in some way. In other words, the ball must work to get this energy. Now, assuming the ball wants to roll in a specific direction, it needs to understand how much work is needed to be able to move in that direction. For the ball to figure this out, all it needs to do is compare the movement energy for where it wants to go to where it is currently. And the same could be said about gravitational potential energy. Now, this ball doesn't live in a perfect world. No matter how excited it is, there will always be obstacles that will prevent it from getting excited and stopping its energy from thriving. Some examples of these obstacles would be friction, which slows down the ball's movement on the ground, and air resistance, which slows down the ball's movement due to gravity. Now, although both of these obstacles, known as non-conservative forces, reduces the energy in the ball, energy cannot be destroyed. So it can be thought that the ball isn't losing the energy, but rather sharing it with other objects, allowing for the ball to spread its love of energy throughout the world.